Couple last ideas. Somebody gives you this and says, what's the domain? Basically what they're saying is, what values of x can you put in here where you won't have any problem? If you put 3 in here, you get square root of 0. That's not a problem. Anything bigger than 3 is not a problem, but a number smaller than 3, like 2, 2 minus 3 is square root of negative 1. That is a problem. So the number x minus 3 has got to be either positive or it's got to be equal to 0. So x minus 3 has got to be greater than or equal to 0. So we add 3 to both sides. The domain is x is greater than or equal to 3. So you can write this as, you can write this in interval notation as 3 to infinity. Another question will be something like, hey, show me that you know how to do synthetic division. 2x to the third minus 3x plus 1 divided by x minus 4. So the leading coefficient is 2. Notice it's x to the third. There's no x to the second, so you put a 0. Then we got x to the first. Now I made this one up, x minus 4, so you put a 4 here. So I don't think it works out very nicely. That doesn't mean it's we did anything wrong. So in synthetic division, you bring the 2 down. 4 times 2 is 8. Add 8. 4 times 8, 32. Minus 3, that's 29. 4 times 29 is like 4 times 30, which is 120. Minus 4, which is 116. Add, you get 117. So we had 2x to the third and divided by x. So your answer is 2x squared plus 8x plus 29 plus 117 over x minus 4 is your remainder. Somebody may say, solve 25 to the 2 minus x equals 1 over 125. And what you're supposed to notice is the base here is 5. So this is 5 squared to the 2 minus x equals 1 over 5 to the third. 5 times 5 times 5, 125. So when you raise a power to a power, what you do is you multiply. You've got 5 to the 2 times 2, that's 4, and 2 minus x, 4 minus 2x. And this, 1 over 5 to the third, can be written as 5 to the negative 3. So you have the same base. The exponents must be equal to each other. 4 minus 2x equals negative 3. Subtract 4. Minus 2x equals minus 7. X equals 7 over 2. So if you do 25 to the 2 minus 7 over 2, that's going to be the same thing as 1 over 125. How about this? Evaluate. Evaluate. Log base 5 of 125. So this is the one where you say equals x, and you say 5 to the x equals 125. We just said this one a second ago. 5 to the third is 125, so 5 to the x equals 5 to the third. X equals 3. Let's just do a couple more. Somebody may say condense. I hope I spelled that right, but maybe it's an SE, condense. Forgive me if I spelled that wrong. Log base 3 of 27 minus log base 3 of x. With it, let's put a 2 out front here. Notice they're both log base 3. In log language, minus is divide, so you've got log base 3 of 27. And what happens with the 2 here, this becomes x squared. So log base 3 of 27 divided by x squared. How about this? Somebody says solve log base 3 of 2x minus 1 equals 3. So you say 3 raised to the third equals 2x minus 1. 27 equals 2x minus 1, add 1. 28 equals 2x, x equals 14. Let's see if I forgot anything. One more, last one. Somebody gives you a graph like this. Y equals 2 to the x. Okay, put a 0 in. Put a 1 in. 2 to the 1 is 2. So the graph of y equals 2 to the x kind of looks like this. And then somebody gives you a graph that looks exactly like it, but everything is moved up 1 unit. They say, hey, what's the name of this graph? That's y equals 2 to the x, shifted up plus 1. Good luck.